Hey, how's it going, guys? So back again for some more of the Python BACnet Stacks playground. I just want to apologize. I think there is a video on YouTube. It might be not that long ago, lesson 22 or something like that. That someone pointed out that the audio or the video stops, but the audio continues. And yes, that's a problem with a glitch in my I record in OBS Studio, so something must have clunked out on that day of going over the web weather code. So I apologize for that. So after 10 minutes, there's only audio and the video is glitched out. Also, if my voice is coming through kind of hard to hear, I am using a microphone here, so it's first times kind of doing this, so I apologize. I'm trying to work on that too. So yeah, hopefully the mic is cranked up from what I can see in my audio here in my recording studio message, and hopefully this video doesn't clunk out. But hopefully you're following along. If you got to the web weather code base, maybe I'll just try and walk through it again. So we were using a mini device from BACpypes. So on the BACpypes3 repo, if we go into samples, we just to retrace a little bit, we found this mini device right here, and then we converted that into our web weather. Then this is what we're going to work on today. So this is another mini device for a specialized schedule and calendar server. So it's pretty much the same thing, just a couple BACnet points, but then what we have here are special BACnet points that handle schedules and calendar objects, which is maybe something that you run into in the wild on a building automation system as well. So I'm just going to go back into our mini device. This was also our open weather map tester. Remember, we got an open API key from open weather map, and then on one of the videos we just pasted in, this prints the URL, and then with your API key, and then the video you need to create an OS var file. So that was here. You remember, we right click VS Code, create a .env, and then you paste in your coordinates, your units, and then when this ran the other day, when you can just print this, and because it's a GET request, you can just see what the data looks like right in the browser. It'll just display all the JSON because a browser does GET requests essentially. So this is our tester, and then when you want to run the actual code for this, no, I apologize, maybe I didn't put any of the args in here. Did we have args? Maybe not, but shouldn't be too hard to kind of get working. Just go to the Discord. So like, if you have any problems, there's a link for Discord. More than happy to chat with you on Discord. So yeah, this kind of grabbed all of our data from Open Weather Map, and then we had a handy dandy function of converting dry bulb temperature and humidity into a dew point, which is not too hard to do. I think if we were doing wet bulb temperature from dry bulb and humidity, that would be a much more elaborate math calculation, but dew point I don't think is that hard. Then we just created our BACnet objects. So shouldn't be too hard just to follow along in the code on what it does. The hardest thing to remember is, like, when you're creating a server, you have to increment manually your BACnet, your analog values. So this is analog value 2, analog value 1, 3, binary value. We never got into any commandable points, but just remember you have to increment here, because when you add in your objects to the BACnet server and the application, it will error if you don't increment those. And then our web weather fetching, this is just using async.io, the asynchronous Python framework, where we're just one loop is fetching weather data, which defaults to every 15 minutes we fetch new weather data, and then the code just sleeps in between there. So and that's how we can get everything for free with OpenWeatherMap API. If we only run this a couple times an hour, 4 times an hour, which is plenty for getting updated weather data for a building control purposes, it's free. And then this runs every 5 seconds, I think. So 2 internal loops, we continuously update our points present value. And then when we finally cut over to every 15 minutes, that's when we do we switch out our new values. This is where we'd update present value in BACnet for humidity, dew point, and dry bulb. And it's all the same kind of things that we've been discussing in our theory lectures too. For like this right here is a list, and then we're getting into embedded data structures too, nested data structures. Okay, so I might put this to rest. Just getting back here, we're kind of blazing through this coursework a little faster than I thought. So we already did this. This is our final project, our weather station, but I have some other ideas that we can just keep on chugging along with, just applications to make. So I'll keep on updating this the best I can. It's kind of a work in progress. I apologize. I'm kind of new at YouTube and teaching any kind of a coursework. Okay, so now getting back into maybe what we could play around with today. So I think that's all I have to say. So here, this is our AI generated coursework, and then we're kind of on day 23 here, which I also might come back to. Okay, so on here, maybe I'll just put this on day 24, because maybe we could get into both of these. Okay, our mini calendar device. So I'm just going to copy this, and then let's just, we can just create this into our vibe code app 4 section, a new app to play around with. Let's just copy some code. So I probably won't get into this too much, but this is essentially very similar to the OpenWeatherMap code base, but this is actually for schedule objects. So in the building automation system, I don't know if all building automation systems have this, but it's pretty popular. Like, you can see the equipment run schedules from this object called a schedule object, and then it'll show through BACnet dates and times in tuple formats. So we'll get into that. And then there's also a calendar object. So prior to this, we've just been dealing with where's our mini device? Here's our mini device. So analog values, binary values. So now we're going to get into calendar objects next, and schedule objects, which I think are important to cover as a topic in BACnet, because you might run across it. And then when you scrape present value, it might come back as a time comparison of like current time to occupied time, a 1 or a 0 for true or false, or you can get a more robust readout of like an occupancy schedule. So I think we should spend a couple days on this actually. So this is our build a weekly schedule, where we'll just pretend our building automation system has an equipment run schedule of 8 a.m. to 5 p.m. and this will parse, this little function will parse everything out. And yeah, there's a lot to look at here. I think we could probably fill up the rest of our week just on this alone. And then a calendar schedule object, to my knowledge, is a more rich subset of a schedule object. So let's play around with this for a couple days and see how this goes. I might even just wait till tomorrow to send, like, I'll do the same process where I'm on Windows and PowerShell, and then we'll send it over to the Raspberry Pi, and then we'll run the code on the Raspberry Pi in Tmux. So let's probably do that tomorrow, or else I'll be burning through content way too fast. So I'm actually close our SSH section to the Raspberry Pi, and then we can just do our theory lecture for today. So this is our mini calendar schedule, which we'll do tomorrow. And then let's do our script lesson. Another thing I was thinking about on a previous video, this math square root, compute the distance between 2 points entered by a user. So this was our day 23 lecture, and I was kind of like stumbling on how the heck do you do that. So and I was just thinking about this after I was stumbling through the YouTube video. So let's say if we have just kind of thinking, and at the same time, so if we have a graph, let's see, so if we had how should we do this? So we should do some tick marks here. 1, 2, 3, 4, 5. Sorry, not very pretty. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's say we have a point here at, let me draw a dot. Say we have a point here at here, and then another one at here. So let me just 1 second, guys. So if we were doing so okay, getting back to this. Basically, so like, let's just try this. So this is y. Okay, so now we're just doing our theory lecture here, and we'll get on to more BACnet tomorrow. So anyone that is pretty good in computer science, feel free to sign off. But I'm still studying theory because I think it's good. So if we do, let's say that we're at, let's just try this. So if our y-axis is, so this would be, I think, like 2, 1, 2, 3, 4, 5. 2, 5 are coordinates, and then this would be 2, 3, 4, 5, and coordinate of 2. Let's say 1. Just realized I don't have my handy dandy mouse highlighter. Okay, so like, what would be the distance between here and here? So I think, like, I was thinking about this a little bit later, is like, I think it wants us to use Pythagorean and theorem, however you pronounce it. So if I just draw this out, So our distance here is 5. One, 2, 3, 4, 5, and our distance here is 1, 2, 3, 4. I could be doing this wrong too. So, and then if we do find the Pythagorean theorem of a triangle, this would be, I'm just going to Google this because I'm kind of lazy. And I've been out of college for almost 20 years, so square root formula. Alright, so this is what we need to do. Copy. I might just put this right into Python. Ooh, that looked ugly. Well, I'll do this the old-fashioned way too. So I'm just going to say import math to say coordinates 1 equals some kind of tuple. I think it was 2 and 5. Coordinate 2 equals 5 and 1. I'm probably doing something wrong here. I have that sensation, but I think we'll get the idea here. Distance equals, I think we do math dot square root of coordinate 1, index 1, actually I think I might do something a little bit more basic here. So we could do I think this should be x1. I'm sorry. So this should be 0.1, 0.2. I'm going to just call this 0.2. And then we would want to do x1 equals 0.1, slice the tuple. And then we would do x2 equals 0.2. And then we do the same for y's. Except this would be indexing the tuple over here. So let's just print x1, x2, print y1, y2. Let's just try this. Oops, let's do it clear. right? 2 and 5, 5 and 1. Yep, I think so. Close enough. I have a feeling I'm doing something wrong with this. It's been a little while, so I apologize. So, then if we wanted to do the Pythagorean theorem with the distance equals, where are we here? I'm going to do math dot square root wrap x2 minus x1 divided by, oh, no, squared. Okay, so squared plus y2 minus y1 squared. Alright, I hope this is right. I think this will do this first. I don't know if we need another parentheses in here or not, but why not? So we just see if this works. Print distance 5. Seems logical. Alright, I think we successfully traversed the triangle. So that was kind of bugging me the other day when we were doing the lesson, that I kind of clunked out on what this would be. Anyways, a little more thought, and I'm probably screwed something up in that. But I've been out of college for a little while, so I'm using that as my excuse. So let's just try and chug through some more theory lectures for today. So anyone new to coding, I highly recommend just spending time with some of the computer science theory, because it'll make you a better BACnet application developer, and then you can do more stuff with your career beyond building automation systems. So, alright, I'm just closing out of a few windows. Alright, here we go. So let's do day 24. Any, all, simple patterns. Seems like my mouse highlighting tool stopped working. Let's fire you back up again. Alright, there we go. So any, all, simple pattern. Explore Python's any and all functions for checking conditions over collections. Use loops to build data you pass to them. No comprehensions or generator expressions. In the built-in functions all, any, take an iterable and return a Boolean. Returns true. Hopefully that makes sense. So all returns true or false. If every statement is truthy or this iterable is empty, any returns true. If at least one of these elements is truthy and false, if the iterable is empty. Okay, use a loop to test Booleans and then pass it any or all. Okay, so we can pretend these are readings. This is kind of interesting. So let's just see what this prints out. I don't really use this on my day-to-day, so true and true. Okay, so this is actually your expression right here. So it's appending probably a bunch of trues in here. If we would go and we would print 2. It's just holding a list of our Boolean expressions right here. Kind of handy, shorter pattern with a loop. So, okay, let's see if we can chug through a couple of these mini or micro exercises. Hopefully this stuff is okay and there's anyone even following along. I just think it's I haven't done this stuff for quite a while, even using with coding with AI. I think it's good practice. Okay, so here we are. Given values 0, 1, 2, 3, use a loop to build a list and pass it to the any. Check if any of the values are negative. Use another loop all to check if the values are less than 10. Alright, so that was just like this. I'm just going to copy this code. If any of the values are negative. So I'm just going to say, I'm going to do a find and replace, and let's see, so this should be, say, are negative. And then I just have to say if r is less than 0, that'll be true. And then I could say, change this one to be less than 10. Say less than 10. All right, let's try this. Okay, so are all values, if any value is negative, so we need to change this to any. We could even do test here. True, we got a -1. And then we want to do check if all values are less than -10. And change u to null. Alright, pretty easy. Got that one done. Write a function in a range, all in range. Write a function all in range that returns true for every value between low and high exclusively. Okay, so if we made a function, so I assume this is a list. Let me see, so I'm just gonna say, we could do, just say data equals a list. Oh, here we go. So that returns true for every reading. Okay, so we could do just a range loop for I in range. Let's see, these were low and high. Low, high. Let's do print readings at index I. So let's try out our function. Whoops. Oh, come on. So I'm just going to say some numbers here. I'm going to try all in range. Pass in a list of data. Should be, I don't exactly specify what we're supposed to pass into here. And our second parameter would be our low value right here, our low and high. So low we could just say 4, and our high value is that. Okay, list is out of range. I think I need to do length readings. Okay, so we successfully passed in our list to this function, and then we're just printing the values in this list. So we would want to say let's see, so just say, I'm just going to say is between low and high equals false. Okay, so we're going to do a Boolean expression here. So if our values in our list is we just want to say greater than or equal to low and readings I is equal to or less than high. I'm going to change this to equals true. All right. Let's just try this. Print numbers. Hopefully this makes sense. This right here is our readings, and then this would be our low and our high. And then in this little range loop, we're gonna iterate through all these values, and then if a reading is greater than or equal to the low value, and it is less than or equal to the high, we can say that our readings are between the low and high. True. So if I put this down to, let's say, 10, false. All right, I think we passed that one. Sorry, these videos are probably very dry and boring, but okay, so write a function, any alarms, reading or threshold. I'm just going to recycle this one. Call this our threshold. So right now we can pretend that this is our we call this temperatures. Ooh, sorry. I'm actually going to put this in the new list. Maybe I'll just make up new data. So temperatures, we could pretend that we're reading through BACnet. a list of data. Make up some floats. This one would be an alarm. And just whatever, this is just some random data. Let's say it's okay, so this value right in the middle would be an alarm. And we could say alarm is anything above 50. Oops. We can just call this a check. We're going to check and see for an alarm. Alright, so if we were playing around in BACnet, let's say we did have a BACnet application where we're reading data across the network and we want to dial out like a building automation system would. This is how we could do something like that. Yay, we would dial out. Change that to some more realistic numbers that are below our alarm threshold. And it's okay. Now it's saying why would this be an alarm? Okay, so if our alarm value is 50 and our data is good. Oh, okay, I have this wrong. We wanted to say if our readings, if our temperatures are greater than our alarm, then we would want to dial out. There we go. So if we put this back to some really high value, 422, yep, we would dial out. Okay. All right, daunting. Sorry guys, I know this is probably anyone watching these theory lectures, it's yeah, it gets a little probably dry and boring. So until then, I'm gonna try and be a little bit more you know, let's finish this. I think this we could get to do some cool things here. So tomorrow we'll do day 25 and then get to the rest of our our calendar BACnet object. So thanks guys, long one, sorry. So talk to you later.